right, good morning. Today we are going to review how to graph various types of quadratic equations in different forms. So we're going to go over one of each type first. So the first type of quadratic form that we see here is one that's in standard form. And the standard form quadratic equation doesn't have any parentheses, so that's how we can kind of recognize that that's the one that we're dealing with. Now, when it's in standard form, we're going to identify our A, our B, and our C. So the A is always the number that's in front of the x squared, so the coefficient there, which in this case would be -1. The B would be the coefficient for that middle term, the x, so the B in this case is 10, and then the C would be this -30. Okay, so a couple things. So if we're going to find the vertex, we might want to know, is it a minimum or a maximum? And how would we be able to tell that? So first thing I'm going to look at is my A value. So since my A value is a -1, I know that this parabola is going to open downwards like this, which means the vertex will be at the tippy top of my parabola, and this will be a maximum vertex. Now, to actually find the vertex or the axis of symmetry, we want to use that little formula -b over 2a. So if we're going to put in the -b, that would be -10, and then 2 times -1 for the a. So if we simplify that, we get -10 over -2, which simplifies to +5. So that 5 will be the first half of our vertex. It will also be the axis of symmetry, but remember that should always be written as an equation, x equals 5. So once we have the first half of the vertex, we can now plug that 5 into the original equation, and you can certainly do this on a calculator if you'd like. Make sure you put parentheses. So 5 squared is 25, so I have -25 plus 50 minus 30, so that will give me a -5 for the y value of my vertex, which will be the highest point on my parabola. So now when I go to graph this, I'm going to graph my vertex, which is +5, 1, 2, 3, 4, 5, -5, 1, 2, 3, 4, 5. My axis of symmetry is the vertical line going through that vertex point. And then we can use the graphing pattern, which is the A value, which is -1 in this particular problem. And we're going to multiply it to 1, 3, and 5 to get some more points on our graph. So that would be -1, -3, and -5. So we're going to use those numbers to tell us how many boxes we're going to go down on the graph, and then we're always going to go 1 over to the side. So down 1 over 1, then down 1, 2, 3 over 1, and then if you could fit it, you would go down 5. Same thing on the other side of the axis of symmetry, and that's how we make our parabola. Now, we also want to mention x-intercepts and y-intercepts. So in this particular graph, we can see that there are no x-intercepts because it does not cross through the x-axis. This is our x-axis here. It does not cross through anywhere, so there are no x-intercepts. The y-axis, however, there might be if we continue this graph further down, but we kind of ran out of some space. However, I can tell that there's a y-intercept because it's this c value in my original equation. So my y-intercept is going to always be the point 0, comma, and then whatever you get if you substitute in a 0 for the two x's in the equation. Now, I already know, since this is standard form, that my c value is going to be my y-intercept. Because if I were to plug in a 0 for each of these x's here, those would both cancel out, and I would be left with y equals -30. Okay, so moving on to the next example. So the next example is going to be in vertex form. This one here is vertex form. And I think vertex form is the easiest to graph by hand because the vertex is just the h and the k. So if you remember, your a value is this number out front. So our a value here is -2. Our h is the number being subtracted from the x, so that always has to switch signs. So my h here is going to actually be +2. And then the k value is the number that is at the end here, which keeps its sign, so that's going to be -1. Once you get your vertex, your axis of symmetry is just x equals that first value there, which is 2, so x equals +2. And because my a value was a negative, we know that this vertex is also going to be a maximum. So if I go ahead to plot this, go over 2 and down 1, I make my vertex point on the graph. I can do my axis of symmetry going through that point. And then I can use my graphing pattern, which was -2 times 1, 3, and 5 to get some more points. So -2 times 1 is -2, times 3 would be -6, and -2 times 5 would be -10. And the 1, 3, 5 you just always use for quadratics. So from my vertex, I'm going to move according to my graphing pattern down 2 and always over 1, then down 6 over 1. Then I would go down 10, but I'm kind of out of space, so I'm going to go on the other side of the parabola. And there is my parabola. Now, a couple things, right? So the y-intercept is the point that you get when you substitute 0 in for x. But in this case, it's a little crooked here, but I can actually see it on my graph here. It is 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes down, so I know that's a -9. If you substituted 0 into the original equation and you did 0 minus 2, you'd get -2 squared, which is 4. 4 times -2 is -8. Minus 1 would give you that -9 as well. Now, as far as x-intercepts are concerned, for this particular problem, there are none because the graph does not cross through the x-axis anywhere. The last thing to note about this quadratic equation is that because the a value, the absolute value of that a was 2, and that's greater than 1, the parabola got a little bit narrower or thinner or skinnier, whatever word you'd like to use, than the one that we did in number 1, which had an a value of -1. So we move on to number 3, this equation here, since our a value is going to be 1/2, which is smaller than 1, we're going to notice that this one is going to get wider. Okay, so that brings us down to the third example. This form here, when we have the two sets of parentheses with the a value in front, is called intercept form. It also can be sometimes referred to as the factored form. Okay, so either of those is referring to the same thing here. So in this particular case, I'm going to write the equation for a second. We have a times x minus p times x minus q. So in this particular example, my a is 1/2. My p is going to be the number being subtracted from x. So we have to do a sign switch there. Since this is a plus, it's actually -4. And my q, again, the number being subtracted from the x, which in this case is the +1. Now these numbers here, -4 and 0 and 1, 0. So if you take the p and the q and you write them as ordered pairs, these are your x-intercepts, also known as your zeros if you were factoring, and they're actually 2 points on your graph. So you already know where this parabola is going to cross through on the x-axis. Now, because my a was a positive, I know my graph's going to open up, and I'm going to have a minimum vertex here. So in order to get that x value, I could average out my two intercepts by adding them up and dividing by 2. And when you add up P and Q and you divide by 2, you are actually going to get negative 3 over 2 or negative 1.5. So I'm going to make it a decimal. All right, and then we know that that is our axis of symmetry going right through here at negative 1.5. But we have to find out where or what the y value is so we can actually plot the vertex on there. So to do that, we're going to take the x value that we got, which was negative 1.5, and we're going to substitute it in the original equation and get the y, and you can do it on a calculator. You should get negative 3.125. So I'm going to go over to my negative 1.5, go down 1, 2, 3, and a smidge past that third line there. And I know that that's about where my parabola is going to kind of line up. Now I'm just drawing my curve through. It's a little crooked, but you get the idea. Now the axis of symmetry is just x equals whatever that x value was in the vertex, which in this case was negative 1.5. And if you wanted to do some more points using your graphing pattern or graphing calculator, you could. So if I were to do the graphing pattern here, it would have been 1/2 times 135. So it would have been 1/2 3 over 2, or 1.5 5 over 2. So if I went up half a box here and over 1, it would be right around there. So this one's a little bit crooked, but and then I would have to go up 1.5 boxes. So I think it would end up, I don't know, right around there probably. So, you know, it would just line up a little bit nicer. Now, again, we have our x-intercepts right from the beginning because it is the intercept method. So you get them right out of the beginning of the problem. But the y-intercept would be this extra point here. Where is it crossing the y-axis? So it looks like it's at -2. So it looks to me like my y-intercept is 0, -2, but how can I be sure it's not some kind of a decimal? Well, if I put zeros in for my x's in the original problem and solve it, I would have 1/2 times 4, which is 2, and 2 times -1, which would be -2. And that is how you graph quadratics in either the standard, vertex, or intercept forms. Okay, so then on the next page, we have 4 problems here where we are going to go from the intercept form to the standard form, or the vertex form to the standard form, by using our multiplication of binomials and things like that. So we're going to mainly be using the distributive property here. So if I take a look at number 4, I'm multiplying -2 and the binomial x minus 6 and x plus 4. So it doesn't matter what order you multiply them in. So you pick any 2 you want, multiply them, and then you would multiply the product of those to the third one that you didn't do yet. So I typically like to do the 2 bigger items, or the bigger terms here, which in this case would be the 2 binomials. I like to do those first and then distribute the -2 to everything after. But you can do the -2 to one of them and then the answer to the other one if you'd like. So first I'm going to do these 2 here. So when I do x times x, I get x squared. X times 4 is 4x. Then -6x, and then -24. Now, anytime you have like terms, it's always a good idea to combine them. It just makes your product a little bit smaller and more manageable to work with. So 4 minus 6 is -2x. Okay, so now you think we might be done, except we never multiplied that -2 into there yet. So we're going to take that product we just got and multiply the -2 in by distributing. So we're going to have -2x squared plus, because negative times negative is a positive, 4x, and then plus 48. And that is our answer to that one. Okay, so number 5, same concept there. So again, I'm going to start out, well, actually, you know what, this time I'm going to multiply like these 2 first so you can see how it kind of works out if I do it a different way. You could still do it the same way we did number 4 if you'd like. So if I do this one, I would have negative 3x and then minus 18. And then I would have to FOIL that to be x minus 8 or distribute. So I would get negative 3x squared plus 24x minus 18x, and then plus, let's see, what is 18 times 8? I think it might be 144. And then the middle two are like terms, so those can be combined by adding the coefficients. So we have 24 minus 18, which would give us 6x in the middle, and that equals 144. All right. So that is how you would change something from intercept form back into standard form and get rid of all those parentheses. Okay, so then the next two are in vertex form, and we want to change those into standard form as well. Now, the key is when you're doing something like number 6 or 7, where you have this binomial squared here, a lot of people make the mistake of writing x squared minus 4, and they forget that this is actually x minus 2 being multiplied by itself, which would be another x minus 2. So that's one mistake that's common to make there. So please be careful with that. So I just like to write it twice so I don't get confused. And then I just do my distributive property. So x times x is x squared minus 2x. Multiply the middle, negative 2x, and then positive 4. I have like terms in the middle there, which would be negative 4x. Now, you'd think this is the answer. However, we also had this minus 6 at the end. So I have to make sure I combine that with any other like terms. And I do have that 4 there. So when I combine that, I get 4 minus 6, which is negative 2. So my answer here is x squared minus 4x minus 2. And that's now in standard form. Okay, and then finally, the last one. Again, we have this vertex form here where I'm going to write this binomial twice so that I know that it needs to get multiplied correctly. So I'm going to do x times x, which is x squared, x times negative 1, negative 1 times x, and negative 1 times negative 1. Combining those two like terms in the middle gives me x squared minus 2x plus 1. Now I have to remember I still have this 5 to distribute, and then I have that plus 7 at the end that I'm going to have to combine in. So first, just like in PEMDAS, you always do your multiplying before you do any addition. So I'm going to distribute the 5 to everything. So I have 5x squared minus 10x plus 5. And then when I add my 7, it can combine with that 5 at the end. So I have 5x squared minus 10x plus 12. Now I have converted my vertex form equation into a standard form quadratic equation. Thanks. See you tomorrow.